All right, so we're going to continue on. We're looking at cubic functions. Now, if you remember from last lesson, Noah, we had a chat about types of polynomials. We know this is a cubic function because the highest power is 3, right? We have x to the power 3. That's our highest power, our highest degree, cubic function. Now, we're not expected to factorize cubics like you are quadratics. All right, remember how there's a quadratic formula and you just punch the numbers in and solve it? There is a cubic formula, but it takes like a page of working. So it's just sort of ridiculous. Why follow an algorithm for a page of working? So you're not expected to do that. Some of them can be a bit simpler to factorize though, like this one here. Because if we're looking along here, there's something that's common to all 3 of these terms. X straight away. We can express it like this. Alright, so all I've done there is factorize the x. And now, if we're going to fully factorize it, well, this thing inside, that's a quadratic. And we know how to factorize quadratics. We can do that using the cross method, right? We're just focusing on the inside here. Alright, so I'm looking for 2 numbers that multiply together to give me positive 8. And when you add them, you get minus 6. Alright, so that's going to be minus 4, and minus 2. Minus 4 times minus 2 is positive 8, and minus 4 plus minus 2 is minus 6. So now we have fully factorized this cubic function. Alright, now just following on with that, let's think about what is meant by things like roots, okay, zeros, x-intercepts. If we're going to graph this, all right, it's going to cross the x-axis somewhere, right? We call them the x-intercepts. We also call them zeros because you put that number in, it makes it equal to 0, and we also call them roots. If I'm going to say, what are the roots of this quadratic cubic? What are the roots of this cubic? They're the values that make it equal to 0. Alright, they're the values of x that make it equal to 0 because if you think for any graph, it crosses, Noah, the x-axis when y is 0. So all I've done there is put a 0 where the y is. And if we're going to solve this, we're applying the null factor law, but on like a mass scale, right? We've got either x is 0, or x take 2 is 0, or x take 4 is 0. Okay, solve it. So I've said that one's 0, that one's 0, or that one's 0. We're just applying the null factor, right? So our solution then, x is 2 or x is 4. The roots of this cubic are x is 0, x is 2, and x is 4. That's where it crosses the x-axis. What's the y-intercept of this cubic? Y-intercept occurs when x is 0. So you'd have 0, take 0 plus 0. What's the y-intercept? 0. It would be 0 in this circumstance. So you'd have everything you need to graph the function, right? What else to say? So they're the roots. Now, what do you notice about this number? And if we put it into this function, all right? If we take the number 2 and we put it into this function, let's do that. When x is 2, y is going to equal 2 to the power of 3. Take away 6 times 2 squared plus 8 times 2. I'll just do that in my head quickly. What do I get? 2. 0. All right, y. Let's make a connection. What have we done here? We've found the values of x that make y 0. All right, they make this equation. This equation is equal to this one, is equal to this one. We've said we've found the values of x that make it equal to 0. And so then if I put this value in either here, or if I put it in here, it's going to make the whole thing equal to 0. This is an x-intercept. It is a 0. It is a root. It is one of the factors. Okay, so let's move on to the next question then. With this question, right, It says fully factorised. It doesn't say find the roots, I don't reckon, does it? Fully factorised. So you get full marks here. Okay, this here's just a bit of an extra explanation. All right, fully factorise this cubic given x equals 2 is a root. Okay, if x equals 2 is a root, what it means is x take 2 is a factor. All right, now I've deliberately set it up like this. If x equals 2 is a root, then x take 2 is a factor. Have a look back here. We saw x equals 2 is a root. This is important. What's one of the factors of this cubic? X take 2. Okay? If x equals 2 is a root, then x take 2 is a factor. It applies for any polynomial. If x equals p is a root, remember from quadratics, then x take p is going to be one of the factors. All right? So if we have x is 2 is a root, or a 0, might be another language, or an x-intercept, some more language, then x take 2 is a factor. And what this means is x take 2 multiplied by some function is going to equal this one. Now, this is a linear factor. We call it a linear factor because the highest power is 1. What do I multiply a linear by to get a cubic?
A square.
Has to be a square, it has to be a quadratic. So there is some quadratic in here that we need to multiply it by. All right? And so this is where we're combining what we learnt on Tuesday, because we're going, what's this quadratic? And then we can factorize this quadratic, right? So this is the skill we did Monday. All right? So we should be okay with this next part that follows. The only new part is saying if x is 2 is a root, then x take 2 is a factor, and we have to multiply it by some quadratic to get the cubic. So Harry, let's go ahead and do that. We're going to have, I'm going to perform the expansion. Ax to the 3 plus bx squared plus cx. Okay, that's just multiplying the x through. Next, we will multiply the 2 through. So I'm going to have minus 2 times ax squared, and I'm going to write it underneath, right? I stagger them so that I can collect like terms a bit easier later on. So I go minus 2 times ax squared. I'm writing it under this one because they're both x squared. Next one, minus 2 times bx will be minus 2bx. And minus 2 times c will be minus 2c. All right, next let's collect these ones. All right, so I'm just looking down, we've got ax to the 3, I've got b take 2a of x squared, I've got c take 2b of x, and I've got this minus 2c hanging out. All right, so just collecting them vertically. A by itself, b take 2a of x squared, c take 2b of x, and then this minus 2c hanging out. And now we're just equating the coefficients, right? I've got ax to the 3 equals x to the 3. All right, so a has to equal 1. The coefficient of the x cubed term has to equal the coefficient of the x cubed term.
C must equal 4.
Yep. Let's just move along. So we've got b take 2a is going to equal minus 7. All right, the coefficient of the x squared term, b take 2a, has to equal the coefficient of the x squared term over here. Let's go through and solve for this one. We need to use the a value that we've found, right? We've got a is 1, so we'll have b take plus 2. Alright, so you can keep going across if you want. You can use that one, but Noah's correct. It's much easier to just use the last one. We have minus 2c is equal to minus 8. Alright, the constant term has to equal the constant term. And so here we'll get c is positive 4. So we've got the values of A, B, and C. Now, if you move on to do spec maths, either this year or next year, when I'm looking at this, right, so this isn't something you have to do, but it might be something you can notice. A has to be 1, just from looking at it. So you don't even need to include the A term there with the expansion. A has to be 1, all right? And you can also know that C has to be positive 4 because the only constant term is minus 2 times C. So if you can see that, you can make note of it. If not, just follow the process I've performed here. All right, so we're not finished though. All right, all we have done is found this quadratic. So I'm just going to rub this out and we'll continue up here. So we've got x take 2 multiplied by ax squared plus bx plus c. We found a was 1, x squared, plus bx, and then plus c. This cubic is equal to this cubic here. Alright, remember we've said, here's the cubic, it has to equal a linear times a quadratic. Here's the linear, here's the quadratic. Alright, so they're equal, that's fine. They're different ways of writing it. The question says fully factorise. So that means it wants us to factorise this term in here as well. And we can do that one, that's a quadratic, just focusing on that, using the cross method. That's going to be x take 1 and x take 4. Alright, so it's fully factorised. And in fact, you can see the roots, alright? You can see the roots. You already know one of the roots is x is 2, but the other roots are x is 1 and x is 4. Alright, they're the roots. Putting x in there would make it equal to 0. What about the y-intercept of this cubic? Y-intercept occurs when x is 0. If x is 0, minus 8. Alright, if x is 0, y would be minus 8. So that's just a bit of getting you to think about it, but you're getting full marks at this stage here. Alright, that's what they're looking for. Now, this cubic can be fully factorised into 3 linear factors. Isn't that amazing? Look at this. A linear factor, so that's x to the power of 1, times a quadratic, gives you a cubic, x to the power of 3. And here we can have a linear factor times a linear factor times a linear factor. Alright, 3 linear factors also give you a cubic. How many linear factors to make a quartic do we reckon? 4. Spot on. Alright, so quartics are not much more of an extension of cubics. And you can just go on forever, really, because the same rules apply. Alright, so let's have a go at 4e. That's what we'll dedicate our lesson time to today.